चलो we start with inorganic में coordination compounds. उसमें नहीं होएगा. The only inorganic chapter probably जिसमें we don't have to really memorize anything. अच्छा एकदम conceptual based chapter है. Light क्या हो गया रे? हाँ करता हूँ मैं. वो मेरे तो कैमरा में दिखेगा ही नहीं. Okay. चलो. Now salts are divided into two categories. सबसे पहले salt that we've learned they're called as simple salts. ठीक है. What do you mean by simple salts, people? जैसे कि for example, if I take NaCl, you take NaCl. How do you get this simple salt? NaCl वाला salt कैसे मिलता है, people? You take HCl plus NaOH. क्या देता है अपने को वो? NaCl plus H2O, and this is your simple salt. Now you take this simple salt. In its aqueous solution, which ions will be present? Na plus and Cl minus. How do I know that these ions are present? कुछ टेस्ट कर सकते हैं. I think people have done test for cations and test for anions. क्या है ना effect में? ठीक है. Now, for example, let's say कि ये if I treat this with AgNO3, what do I get here? AgCl. बराबर. What is the color? So white PPT मिला, तो that confirms the presence of chlorine. Similarly, sodium का भी कोई टेस्ट कर लिया, we can see that Na plus cationic detection. Okay, now these are called as simple salts. Now the second category that we have, second category of salts, they are called as addition salts. Molecular addition salts, या simply कभी कभी हम लिखते हैं उसको addition salts. As the name suggests, they're formed by addition of different salts. And इसका भी further category है. They're further categorized into double salts and complex salts. Now what do you mean by double salts? You will have done double salts in 10th standard. For example, मेरे को ये कौन सा डबल सॉल्ट है बताओ. Let's say I have if I take K2SO4, Al2SO4 thrice and water, ठीक है, and I cool this. Which salt is this, people? K2SO4 dot Al2SO4 thrice and 24H2O. You've done this in 10th standard. What do you call this, people? Alum, or specifically potash alum. It's the OG aftershave. People have heard something called fitkari. पुराने आजकल भी यूज होता है, बट आई डोंट नो. हाँ, इट्स अ स्टोन लाइक थिंग. वो शेविंग करने के बाद. हाँ हाँ, correct, exactly. So this is potash alum. Now, people, if I make an aqueous solution of potash alum, I repeat, if I make an aqueous solution of potash alum, okay, I'm making an aqueous solution of potash alum. Which all ions will be present? There will be K plus and Al 3 plus and SO4 2. So basically a salt or a double salt in its aqueous solution will show properties of its constituent ions. What are the constituents ion in potash alum? Potassium, aluminium and sulfate. So double salt show, like salts, these salts show properties of their, or you can detect their constituent ions, properties of their constituent ions in aqueous solution. Is it with me? Let's take one more double salt. Let's say, for example, this one. Let's say we have KCl plus MgCl2 plus 6 H2. Again, on cooling this, we get KCl dot MgCl2 dot 6 H2. This is called as carnallite. People have heard about this before? No. Okay. Carnallite can give me the constituent ions in its aqueous solution. Okay. And similarly, we've done more salt. Then sand में more salt. Give me more salt, please. More salt. Again a double salt, which is NH4 twice SO4 dot FeSO4 dot 6 H2O. This is also called as ferrous ammonium sulfate. ऐसा दिया क्या पहले? ओके. ये क्या कर रहे हैं शान? ठीक है. Maybe we will get that. Any questions still here? What's the double salt? Next, there's something called as people double salt. First, addition salt में the first type is double salt. Second, what do you call them as? Complex salt. अभी ये chapter में we will learn more about complex salts. What exactly are complex salts? The पूरा chapter is made up of complex coordination compounds. Okay, so let's say we have Fe2 plus, and I'm treating it with excess of KCN. Now let's say what we get here is K4 or let's say we get something like this, K4 FeCN6. For the time being, you will not get the nomenclature. We'll study nomenclature of coordination compounds later. Okay, let's say we get a complex or we get a salt, something like this, which is this square bracket में जो लिखा है ना, we call this part as complex part. Later half of the chapter में हमें समझता है what is. Probably next lecture में समझेगा. तो अगर आज ही हुआ तो आज ही will learn why do you use the word complex. Now people, if I put this in aqueous solution, this gets divided into 4K plus FeCN 6 raised to 4. Now tell me, if I try to detect ions over here, which ions should we detect? We should detect potassium, we should detect Fe plus 2, we should also detect cyanide. However, aqueous solution में we can only detect potassium. If you try to detect Fe plus 2 या फिर for CN, it shows negative test. Though this part is yes, थोड़ा सा feebly ionizable. But the degree of dissociation is extremely small. और हम बोल सकते हैं कि alpha is almost 0. So in Marrow, then such salts which do not show properties of their constituent ions in aqueous solution, such salts are called as complex salts. I repeat, what are complex salts? Salts that, or salts which do not show properties of their constituent ions in aqueous solution. Then such salts are called as complex salts. So, complex salts, people are further classified into perfect complex salts. And give me the second one. What will the second one be? Imperfect. And now you people tell me, what do you think is perfect complex salt and what are imperfect complex salts? आप बताना कि what is perfect complex salt में? No. The degree of dissociation will be 0. Non-ionizable. Or in imperfect complex salt, even the complex part is slightly ionizable. क्या बोलेंगे हम imperfect complex salt में? Even the complex part is slightly ionizable. Do you people get that? Someday, let's take one more example for a complex salt. Let's say we have Cu2 plus and I have KCN. Okay, so what we get here is K3 Cu, sorry, let's have Cu2 plus and cyanide ion, Cn minus. Now what we get here is CuCN2. Now CuCN2 is unstable, and this breaks down into CuCN plus Cn2 gas. Now this CuCN again, if you treat it with excess of KCN, what we get is K3 Fe, K3 Cu CN4, and this in its aqueous solution will give me what, people? K plus CuCN4 3 minus. Now, what's the charge on Cu over here? 2 plus. यहाँ पे, can someone give me what's the charge on Cu? What's the charge on potassium? +1. Cyanide? -1. Now give me the charge on Cu. +1. So from +2, it's complex, it's becoming nature of Cu2 plus. Oxidizing agent. We did this in D block elements. Now what about here, Cn minus? If this is oxidizing, this is did people get that? ठीक है, चलो. Second part of the chapter में बताता हूँ why is it unstable. Yes, recording. नहीं हो जाएगा because that is output ना. Okay. चलो, now we will pay attention. So we have, now let's get into the chapter. वो सिर्फ introduction था. So let's say we have a coordination compound, something like this, K4 Fe CN6. So there's a part which we write in square brackets. That part is the non-ionizable part of the coordination compound. जिसको अगर हम बोलेंगे coordination compound, and the part that we write in square bracket, ये part को हम क्या बोलते हैं people? Non-ionizable part. It's also called something called as non-ionizable sphere, which we'll do later. You also call this as the complex part of the coordination compound. If this is the non-ionizable part, what is the other part? This is the ionizable part. Or it is part of which sphere? Ionizable sphere. ठीक है, एकदम बेसिक है. Square bracket के अंदर what we have is, we have a central metal atom or a central metal ion, usually a transition element. Remember D block में हम पढ़ रहे थे वो complex forming abilities. Why do they have complex forming abilities? Why do D block elements have complex forming abilities? Because of the presence of empty d orbital. So they show variable oxidation states. Okay, all that is because of complex forming properties, because of empty d orbitals available. Now, so this there will be a central metal atom present. Along with that, what we have here, these are called as, आप लोग जो DNF में पूछ रहे थे, ligand. ठीक है. If I try to write a general representation, people, of only the complex part, सिर्फ complex part, तो general representation कैसे होता है? You'll have some central metal atom and you'll have a ligand. How many ligands are here? 6. एक ही टाइप का 6 ligand है. So they'll have some ligands. What's the charge on the complex part over here? 4 minus. So either you can have a cationic complex, means the complex is carrying a anionic complex, negative charge, and cationic complex, depending upon, and we don't know +2 +3 +4 +5 क्या है. So the complex part ka representation can be that. So what exactly is a ligand or a ligand? A ligand is, or ligands donate lone pairs of electrons to the central metal atom. I repeat, they are electron pair donors and they donate electron pairs to the central metal atom. How can the central metal atom accommodate these lone pairs? Because they have empty d orbital available. Now, since they are lone pairs, since they are electron donors, we can also call them as next है ना Lewis base. और क्या बोल सकते हैं मैंने बराबर जोर से the nucleophilic बराबर. Since the central metal atom there is a electron pair acceptor, Lewis acids. और एक नाम please. You can also call them as electrophiles. Excellent. They are not electron deficient, but we all are trying to reach stability. How will Fe reach stability? Give me the charge on Fe over here. Plus 2. Fe atomic number. I'm sorry. 26. So Fe plus 2 will be 24. Each CN, अभी तक मैंने पढ़ाया नहीं, मैं बता देता हूँ. Each CN is giving one lone pair to Fe. So it's giving one lone pair. Means how many electrons is it giving? 2 electrons. How many CNs are there? 2 6 are. What was number of electrons with Fe were? How 24 plus 12? 36. 36 is which noble gas? Krypton. So there's a reason why you have an exact number of ligands present. Oh, this is called as effective atomic number. तो सबसे पहले अगर आपने सवाल पूछा कि why is Fe accepting these electrons, because it's very obvious, it wants to reach the nearest noble gas configuration. So जितने भी 3D elements हैं, they would try to reach krypton. 3D के नीचे चले जाएंगे तो उसके नीचे वाले the 4D elements, they would try to reach argon. वाह, Xenon. They would try to reach 54. ये हम effective atomic number में पढ़ेंगे, but आपको समझ आइए, ठीक है? Now, since ligands are donating electrons to central metal atom, and they're forming which bonds? Coordinate. And form coordinate bonds. And they form coordinate bonds. इधर तक any questions? Now, depending upon the number of lone pairs donated, we classify that as denticity of the ligand. I repeat, how do you define denticity? Number of lone pairs donated by number of lone pair a ligand can donate. Getting that? Okay. And the total number of lone pairs donated to the central metal atom, this is called as coordination number. So, how will you define coordination number? Can I say coordination number can also be total number of coordinate bonds formed by the central metal atom बोल सकते हैं, or the total number of lone pairs donated by total number of lone pair of electrons donated by ligands to the central metal atom. समझे people? Yes or no? For example, cyanide, ठीक है, in the form of a ligand, cyanide is called as cyano or cyanido. Okay, I'll give you the nomenclature for ligands. Donates one lone pair. How many cyanides are here? 6. So total number of lone pairs donated to the central metal atom? 6. So in this case, what is the coordination number over here? 6. So ये particular K4 FeCN6 के तो यहाँ पे लिख के देता हूँ मैं K4 FeCN6. The coordination number here, people, is 6. With me? अभी तक? And I repeat, how do you define denticity? Number of lone pairs a ligand can donate. Correct. और monodentate बोलते हैं उसको. अभी वो करेंगे denticity. Denticity does not really depend upon number of lone pairs. For example, let's say if I consider chlorine, number of lone pairs 3. Okay, so it's not that its denticity will be 3. Its denticity remains. So number of lone pairs in any particular species with the number of to its denticity ऐसा कोई relation नहीं है. समझ में आ रहा है? बोलो रे. Then कुछ simple key points है वो बस याद रखना है. Something called as homoleptic complex, and we have heteroleptic complex. What do you mean by a homoleptic complex? Contain only one single type of ligand. For example, यहाँ पे this is a homoleptic complex. It just has cyanide. Let's say cyanide के साथ we had one more ligand. So such complexes will be called as heteroleptic complexes. 15 minutes हो गया रहेगा क्या? It's और 11 minutes पे ना करते हैं. पॉसिबल करते हैं क्या फिर से? चलो ठीक है. Shut up. चलो let's continue people. Okay, let's continue. So we have homoleptic complexes and heteroleptic complexes. Then if a complex carries positive charge, we'll call it as cationic complex, and if the complex carries negative charge, we'll call it as. But a complex can also carry no charge. And such a complex is called as neutral. We did this in D block elements. In D block elements, in oxidation number wala part, my last point tha, where we have written this, where they talk about pi donor, sigma acceptor, sigma donor, pi acceptor, और हमने कुछ ऐसे complexes लिखे थे वहाँ पे. For example, NiCO4, FeCO5. Yes, it's a complex. और यहाँ पे चार्ज क्या पीपल इस पे 0 and 0.
That thing is in the square bracket.
Yes.
इसके बाहर कुछ तो
कुछ नहीं है. It's just complex. You can also tell me the geometry here. 4 sigma bonds. Tetrahedral sp3. Geometry here. because CO is a neutral ligand. भी करते हैं थोड़ा आगे जाके. And since it is neutral ligand, and what about here? FeCO5 sp3d geometry will be trigonal bipyramidal. So next part of the chapter में, not next but आगे I think second, third या fourth lecture में हम करते हैं पूरा isomerism, geometry, isomerism in coordination. Yes, stereo geometrical सब आएंगे. So let's continue. Shut up. So now, people, if a ligand can donate one lone pair, if a ligand can donate one lone pair, then we say that the denticity is 1, and such ligands are called as monodantides. Okay, such ligands are called as monodantides. Now they are further classified into neutral monodantid, then we have anionic monodantids and cation. You have to remember all the ligands which I am writing on the board. So सबसे पहले let's start with some neutral monodantids. For example, actually neutral means charge for all of them will be 0. H2O is called as aqua, or you call them as aquo. Okay. Then we have NH3. Remember this, sir? Even though two lone pairs and denticity has no relation. What about NH3? It's called as amine. Okay. Next we have CO. CO is called as carbonyl. NO, nitrosyl. Then we have after nitrosyl, anyone? Pyridine. Pyridine given by, also written as people PY. Okay. Then we have triphenyl phosphine. Anyone remembers this? कहाँ use किया था ये? ठीक है, triphenyl phosphine. Then you have इसका नाम आप लोग दे देना. We'll call this as trimethyl phosphine. Now all these are neutral monodantids. ठीक है? ईशान बहुत खुश हो रहा है. So next we have some anionic monodantids. सिर्फ anionic लिखता हूँ. Anionic मतलब what charge do they carry? They may carry -1, -2, depending upon the cation which is there. Sorry, the anion which is there. And यहाँ पे in nomenclature we add O or, for example, Cl minus, called as chloro or chlorido. ठीक है, Br minus bromo bromido, iodo or iodido. Next, F minus fluoro or fluorido. Shut up. Now यहाँ पे देखो people, CN में the though I'm writing CN minus, who's the donor? Bonding will take place via carbon. Then this is called as cyano or Sanedo. Yeah. Now, if I write NC minus, isocyano or isocyanide, these are called as, so both of them have denticity what?
1.
But the donor atom can be carbon or it can be, such ligands are called as ambidentate ligands. So what are ambidentate ligands? Ligands where the denticity is the same but donor atoms can change. ठीक है, next. Nitro or nitrito N, which shows that the donor is nitrogen, or you have यहाँ पे हम क्या बोलेंगे इसको, नाइट्रीटो O, showing that the donor is, again these two are called as ambidentate ligand. Next, SCN is called as thiocyanate or NCS. What do you call NCS as? Isothiocyanate. Isothiocyanate. Again, thiocyanate and isothiocyanate both are ambidentates. Next, we have OH minus. What is OH minus? हाइड्रोक्सिडो. समझे नहीं समझा? ठीक है. Oops. तो सेकंड वाला नहीं होगा ना. So OH minus is hydroxido. This is called as per hydroxido, obtained from peroxide. Next. Anyone who can try this? NH2 minus. Amido. Next. N H2 minus इमिडो, ठीक है. नेक्स्ट N3 minus, excellent, azido. ठीक है. ये बस हो गए. कुछ मिस हो गया ना पीपल, आई पुट इट ऑन द ग्रुप, बाकी और कॉपी कर लेना. नाउ वी हैव न्यूट्रल मोनोडांटिड्स, वी हैव अनायनिक मोनोडांटिड्स. उसके बाद कौन से पीपल वी हैव? कैटायनिक. कैटायनिक इतने ज्यादा नहीं है. कैटायनिक विल कैरी व्हाट चार्ज? पॉजिटिव चार्ज. फॉर एग्जांपल NO. NO का नाम क्या था पीपल? नाइट्रोसिल. NO plus is called as nitrosonium. Next NO2. NO2 was nitro. NO2 minus. NO2 plus will be called as nitronium. And anyone इसका नाम? NH2 हाइड्रोजीन, इसका नाम हाइड्राजीनियम. ठीक है. दीज आर कॉल्ड एज कैटायनिक एंड डेंटिसिटी 1. चलो कॉपी कर लो ये वाले. क्या क्या क्या?
उनको सिर्फ डेंसिटी 1 तक का याद रखना.
नहीं, डेंटिसिटी 1 2 3 4 5 6.